All right, so we're going to begin graphing sine today. Now, again, if you have trouble with what we did before, I would encourage you to watch the previous video. If you need help with that, let me know. Of course, you can come in for help. Now, as we said before, we used, sine of theta is equal to y over r, and we know that the unit circle has a radius of 1, which is why it's called the unit circle, 1 unit circle, right? We also said because if r is equal to 1, then y over r becomes y over 1, and of course anything over 1 is just itself. So sine theta is equal to y. And so when I try to graph this, all I'm going to do is you'll notice that on the bottom here, this is my degree measurements, or I should say my angle of rotation, right? I've traveled negative 2 pi, I've traveled negative pi, I've traveled 0 radians, I've traveled pi radians, so on and so forth. And so all I'm doing is I'm going to be tracking my rotation, but again, because I'm trying to graph my sine theta, but because my radius is 1, sine theta is just equal to the y value. So all I gotta do is look at whatever the y value is at that specific rotation. So for example, at 0 degrees, my y value is 0. So all I'm going to do at 0 degrees, at 0 degrees or 0 radians, it is going to be 0. The next one I'm going to look at is going to be pi over 2, or 90 degrees. You can see that the value is 1. I'm going to label the top here as 1, the bottom here is negative 1. My pi over 2 is at 1. At 180, or pi, my y value is again at 0. At 3 pi over 2, or negative 1. 3 pi over 2, or 270 degrees, my y value is negative 1. So I'm going to go all the way down here to my negative 1. And as I rotate pi over 2 more, I have either 360 degrees or 2 pi. I return to 0. And so if I were to connect my points here, now a lot of students are tempted to draw it like this. Okay, I do not want this. I do not want sharp teeth. What I want instead are nice curves like this. Okay, something like that. Now notice that we also can go to the left, and what that means is I have a negative rotation. So earlier we rotated this way, counterclockwise, in order to get my pi over 2, pi, 3 pi over 2, and so on and so forth. Instead, this time I'm going to go the other direction. So this is going to be a negative pi over 2, a negative pi, a negative 3 pi over 2, negative 2 pi. So that means all my values kind of go backwards. I first go to my negative 1, then I go to 0, then I go to my maximum at positive 1, then negative 2 pi, right? So that I'll continue this pattern and I won't get a weird looking thing that doesn't kind of continue the pattern. And of course, you can see I can rotate as many times as I would like counterclockwise. So I can continue going to the right here forever and ever. I can also continue going counterclockwise as many times as I would like, right? So I can go all the way to the left in the other direction as well. So let me just show you, because my graph obviously is not perfect, but this is essentially what we see in the sine function. As it goes around and around in the circle, on the blue circle here, the dotted circle, you can see my sine curve is being graphed out as it's plotting the y values, right? So the second turn here, the second rotation, is going to give me a second complete wave for sine. Now, it's not going to continue, it's going to restart, but that's basically how the sine curve is created. We're not going to watch this video. I can include it in the description below so that you can kind of look at it for yourself, but it's not too big of a deal. A couple vocabulary words that we do want to take a look at. I'm going to actually do the midline first. So the midline is the horizontal line that is between the maximum and the minimum point. So in this case, in my parent function, it's going to be this line right here at y is equal to 0. So this is y equals 0. And I know this because what I can do is to make sure my amplitude, which is this distance from the midline, either to the max or the minimum, is the same. Meaning, If you take a look from the midline and to the highest point here, this distance is 1. From the midline to the lowest point here, this distance is also 1, right? Distance meaning the length. I don't really care about if it's positive or negative. I'm taking the absolute value of the displacement, if you will, right? So all I care about is how far away I am. It is 1 top and down. So therefore my amplitude in this case is 1. And finally, the period is going to be the length of 1 complete cycle. What that means is, notice that for this particular graph or this particular sine, 1 complete wave means if I start at 0, I'm going to go all the way up, hit my maximum. I'm going to then go all the way down, past the midline, go touch the minimum, and then come back up once again to the midline. This will be considered 1 complete wave. I wish I drew that or traced that a little bit better, but this is considered 1 complete wave. Okay, so the green right there, that's 1 complete wave. Now, obviously, you don't have to start at 0, right? That's not a requirement. If you wanted to, you could view this as like, as long as you return to the same exact point, it's going to be considered 1 complete wave. You can look at this as my maximum to my maximum, right? Because I can go down and then back up, and that's considered 1 complete wave. Because again, from my max, I'm going to go back down, right? So this is, at this point, I'm going to start going back down once more, right? In the previous example here, I'm starting at the midline, but I'm headed towards my maximum. Therefore, this is not a complete wave because here I'm going down towards my minimum. I'm not at the same exact spot. Neither is down here because right here I'm only at my minimum, right? This is also not a complete wave. I'm missing that last section right here. Okay, so we do need to consider what is the entire length. And of course, you can see in this particular graph, I'm starting at 0 and I end 2 pi. So this period is 2 pi. It's saying how long was this 1 complete wave? Well, that's 2 pi. And that's consistent if you take a look at it from the max, which is here, to here. This is negative 3 pi over 2. This is pi over 2, right? Pi over 2 plus, again, we're taking the absolute value here. Pi over 2 plus 3 pi over 2, that's 4 pi over 2, which is the same thing as 2 pi, right? So my period is the same no matter where I'm looking at. Okay, that hopefully makes sense to you. But regardless, it is going to be 2 pi for my period in this case. Okay, we're going to be looking at the frequency in just a little bit. I want to kind of give you an example so it kind of hopefully makes a little more sense. Okay, let's take a look at some of the key features we've seen. These are things we've seen before. I hope these make sense to you. The domain, again, as we said earlier, it keeps going to the left and keeps going to the right. For all real numbers or negative infinity to positive infinity, my sine function does exist. Remember, my range is talking about my y values. So my smallest value is -1. My greatest value is 1. So it's going to bounce between -1 and positive. In fact, actually, I'm making a mistake. What I should be here, because it does hit those values, it actually should include both points, -1 and +1. So that's a mistake that I made. Sorry about that. My y-intercept, the only point that it touches through the y-axis is, of course, 0, 0. Okay. A lot of students so far have told me this is even because I'm not quite certain actually. But if it were even, then it should have it has symmetry with respect to the y-axis, meaning if you folded it like a book, right, all the points would match up. It doesn't do that. That doesn't necessarily mean that it's odd automatically, but if you take a look at, let's say I pick this point over here at pi over 2 +1, if I switched my x value, so negative pi over 2, if it were odd, I would expect the point negative pi over 2, -1, and that point is right here. Right, so this is, in fact, you choose any point like that, you'll find the same value. So it is going to be an odd graph. Another thing that you could have done, remember, is to say, well, if I were to, darn it, if I were to rotate this graph 180 degrees, the graph would look identical. In fact, if you take a look, the points do match up, those two that I looked at, right? That's another way to confirm to see if something is going to be odd or not. And we talked about amplitude, we talked about period, we talked about midline for my parent function. So these are the same as what I mentioned earlier. One detail though is this is a line, it's a midline, so I need to have this y equals portion. Okay, please make sure you have y equals in your midline equation. Now, this next portion, we're talking about the periodicity of sine and cosine. Now, what that means is, if you take a look, there's this word here, period, in there. The word period means something that comes out, that is like kind of the same, that's a repeating kind of pattern over and over again, right? So that's why you have like first period, second period, third period, fourth period. It doesn't mean that all of them are, well, in our case, what we mean by that is this is the same time block that's kind of like repeated again and again and again, right? Every single period has the same amount of time. For now, it is an hour long, right? So every period, there's the same amount of time, but they're like different schedule, different blocks of time, right? Now, for us, that means this is going to repeat over and over and over again. Now, if you think about it, if this continues to keep going forever, up and down, max and min, you're going to notice that, well, it doesn't really reach, and there's no end goal or end place that the function will go to. It's going to continue to oscillate between my max and min. So it doesn't have like an end behavior where it's approaching some number. Some might think that, oh, well, on average it's going to 0, but that's not how end behaviors work, right? End behavior is the behavior in which the function is behaving. So it's consistently oscillating between its max and minimum. There is no end behavior. The next few of these key features, they look complicated, but I want you to try your best. Now, I'm not asking you to remember these or anything, but it's supposed to kind of help you to realize how the function will continue to kind of repeat itself over and over again. For example, the x-intercept, you'll notice that I have quite a number of x-intercepts. I have on just negative 2 pi to 2 pi, I have 5. And if I were to extend my graph out some more, I'm going to have more of them, right? In fact, you probably realize at this point that there's going to be actually an infinite number. And so I can label all of them. I'm not going to write down all of them, right? That's not possible because there's an infinite number amount. But I can say 0 plus k pi. I do need a quantifier here where k is an integer, right? Because if you think about what I'm trying to say here, let's say k is 0. Then 0 pi is 0. 0 plus 0 means I have the point 0, 0, and that guy's right here. If k is equal to 1, then 0 plus 1 pi is pi. Pi 0 is right here. If k were 2, 2 pi plus 0 is 2 pi. 2 pi 0 is right here, right? So this is actually going to create for me every single x-intercept. If k is positive, it's going to get all the ones that are positive. If k is negative, it'll get all the negative ones. Similarly for maximum, right? Except now it's not the 0 or on the midline, but instead it's on pi over 2. So again, same deal, plus 2k pi. Do I need 2 plus k pi? I think I do. Yeah, I do. That's right, because it's my period, right? So with 2k pi, that's going to give me, so for example, once again, let's say I have, for this case, let's say I have negative 2 pi, right? So negative 2 pi plus pi over 2, I'm going to have negative 3 pi over 2. And that point is, let me use a different color here. Okay, so if k was equal to negative 1 for this guy, that's right here. Because negative 4 pi plus a positive pi over 2, that's going to be a negative 3 pi over 2, which is right here. If k were 0, then I have 0 plus pi over 2, that's just pi over 2, 1, that's this guy right here. And I can continue counting all the other ones, and similarly for my minimum as well, except now I start a different place. It's negative 3 pi over 2 instead, which is right here for my negative value, negative 1. And increasing, decreasing, again, this looks even more complicated, so I'm not going to talk about it too much. But basically, again, once again, it's saying these features, these characteristics of my sine function will continue to repeat itself over and over and over again because the graph goes on forever with a periodicity, right? It'll continue to repeat itself again and again. So these values will show up over and over again. Okay, and that's all I really want you to know, is that you should understand that the maximum, the minimum, increasing interval, the decreasing interval, the x-intercept, there's an infinite number of them. Now, a lot of times we'll restrict what we look at. We'll only look at negative 2 pi to 2 pi, or 0 to 2 pi, or 0 to 4 pi, whatever it may be. There's going to be a limited number, but that's because we restrict it. Okay. Now, when we graph sine functions, we have our general function a sine of bx plus c, where a is the amplitude. We talked a little bit about that. B is the frequency, or the number of periods every 2 pi. I'm going to expand on that in a little bit. And lastly, my C is my midline. Now, there is an equation for B, which is very useful for us, and we are going to use that. I'm going to show you in a little bit. So let's take a look at this example. Remember that my general form is a sine of bx plus c, meaning a is 2, b is 1, c is 0. If you quickly take a look at just this equation here, a and b can never be 0, right? Because a is 0, then you don't have a trig function. If b is 0, then you don't have a variable. Your variable disappears, right? So it can't be, the smallest numbers a and b can be, or I should say they can't ever be 0, okay? My amplitude is 2, is the same as my a value. Wow, that's a very nice 2. My period, well, my period is actually equal to, well, actually I can look at it here. My b is equal to 2 pi over my period. So b value is equal to 2 pi over my period. So the same thing is true, because if I can multiply by p, divide by b, the same thing is true to say p is equal to 2 pi over my b value. These are both true. In fact, these are if and only ifs. But I mean, you can also just solve for that. So p for period is equal to 2 pi over my b value, which is 1. I should have just written 1, which of course is just 2 pi. So my period is 2 pi here. Okay, and my midline, remember my midline has the word line in it. Y is equal to 0. So that's how I write my midline. Okay, now I'm going to start off by sketching out my midline, because what's going to happen is my graph is continue to oscillate between my midline. It's going to go to the positive side, the negative side, the positive side, the negative side, and so on and so forth. So I'm going to draw in my midline for now. I'm going to draw in my amplitude. I'm going to count out how far away will I be from my midline. So for now, I'm going to be 2 away. So I'm going to go 2 above and kind of draw in. They're kind of like bumpers, right? When you just started bowling, or maybe even now when you go bowling, you have the bumpers set up so it doesn't go in the gutter. It's kind of like that. We don't want our line, we don't want our sine function to go in the gutter. That's going to help protect us to go too far away. Now, generally, this is how I like to graph my sines. I start at 0 at my midline. So at 0, I'm starting at my midline. I look at my period. My period is 2 pi. That means one complete wave will end in 2 pi. So from 0, I go all the way to 2 pi, and this is where I end. So I'm kind of drawing kind of like a boundary. This is my beginning. This is my end. Now, right in the middle between my start and end, I have my another midline point here, which in this case is right in the middle of 2 pi, is pi. Between my first 2 midline points, I have my max. Between my second 2 midline points, I have my minimum. And I can connect the dots like so. Make sure they're nice and curved, but not like mine that are way too curved here. Okay, I don't want sharp teeth. Okay, something like that. And again, I want to go, if I'm going backwards, right? This is now the end point of my previous wave, meaning I need to go down, right? Because this would be the end. I need to go down to go backwards, right? So down means this point here and here and here, right? You could have also said, well, I know that 0 is the end, so, and period is 2 pi, so I have to start at negative 2 pi. Now, you could have done that as well, right? Whatever reason makes the most sense to you, I'm happy for you. Okay, like so. So my complete sine wave will look something like this. Okay, not this is like a saddle. Don't draw like a saddle like what I just did. Don't do that. It's really hard to, I feel like I just can't really see where I'm going with the XP pen. So anyway, it's not supposed to be a saddle. Maybe I'll just try to redraw this whole thing. Negative 2 pi max All right, hopefully this goes well. Oh, all right, last try, last try. Okay, that's not the best, but I think it'll do for now. All right, let's do another example here. I got sine of x plus 1. My a is 1, my b is 1, my c is 1. Okay, and then my amplitude is just my a value. My period, again, the b value is 1. It's going to be 2 pi once again. Again, the math is p is equal to 2 pi over b, meaning 2 pi over 1, which is equal to just 2 pi. My midline is y is equal to 1. Once again, I'm going to draw my midline first. But now, this time, my midline is at y is equal to 1. My amplitude is 1, so this time that is going to be not as high as the previous problem and not as low. Once again, I'm going to start at my midline at 0. So there is my first point. Again, period of 2 pi means I end here. Now I could also start with this guy, this my negative side. That means I have to, because if this is the end, then the beginning must be negative 2 pi. And then in the middle, I also my midline, same thing here. Between the first two is my max. This is the first two. That's my max. Between the second two is my minimum. This is my second two. This is my minimum. And I have my graph that looks like this. Now, again, remember that in our case, we're just graphing from negative 2 pi to 2 pi. But in reality, this graph will continue to the left and to the right forever and ever. Okay, this time we have a lot of changes. 3, 2, negative 2 are my A, B, and C values. Let me just use purple. Sorry. My A value is the same as my amplitude, or I should say my amplitude is the same as my A value. My period, I'm going to calculate that in just a second. But y is equal to negative 2 is my midline. Okay, so y is equal to C. This is what I want. Y is equal to C. Okay, period is equal to 2 pi over b. B in this case is 2, meaning my period is pi. So we actually have a period change this time. So B, please make sure to pay attention to this one. My midline is y equals negative 2. So this time I move down 2 units. And my amplitude is 3. So we're actually very, very far away. 1, 2, and 3. And 1, 2, 3. Okay. Once again, I'm going to start at 0 at my midline. Be careful now, because my period now is pi, right? It's pi. So at pi, this is where I end. So you can see it is much shorter, right? A period means how long is one wave. You can see one wave is much shorter. Now, I'm still going to do the same type of method in graphing. This is my start. This is my end. Right in between is still my midline. Between the first two is my max. Between the second two is my minimum. Okay, so one wave, you can see this time is much sharper. Okay, but again, I want to graph from negative 2 pi all the way to 2 pi. So I have to figure out the whole way through. But same deal, from pi to 2 pi, that's one wave. In the middle, I have my another midline. Got my max in between the first two, minimum between the second two. So this is going to extend out this way, like so. And I'm also going to go the other direction, right? So this is going to be my minimum, my midline, my maximum, midline, minimum, midline, maximum, midline. So my graph looks like this. Now it's a little, like I said, it's a little sharp. Ugh. Oh well. Okay, something like that. I know I didn't. Okay, I'll redo that one. That one's not great. That one's really bad. Oh, that was just as bad. Okay, all right. Now, this is where I kind of want to talk about the B value. And the B value is called the frequency. Okay, the frequency, because the frequency tells me how many waves, we'll go back to the definition real quick here. How many waves or how many cycles are there in 2 pi? So period is saying there's no like defined length. You're looking for the length essentially, right? How long is one wave? How long is one wave? The frequency says in 2 pi, in this set distance of 2 pi, so from here to here, how many waves are there? Now, specifically, I'll draw the midline, so it's hopefully a little more clear here. But how many waves are between 0 and 2 pi? You can see that I have one complete wave here, and I have one complete wave here. Right? This is one wave. This is one wave, which matches my value of B. There's two waves in 0 to 2 pi. Okay, let's take a look at the next one. I have 3, 1, 2, because again, I have a sine of bx plus c. My amplitude is 3. My period is 2 pi. My midline is y is equal to 2. For my midline, once again, y is equal to 2. I'm going to start with that guy. That's right here. My amplitude is 3. Okay, so I'm going to go up 3. 1, 2, 3. And down 3. 1, 2, 1, 2, 3. So I think this actually, yeah, these two are very, very, very similar. This one up 2, this one down 2, but my amplitude is the same, but my period is also slightly different. But you're going to see these two are going to look exactly the same, except for the fact that there's going to be way more in this one. Okay, so let me just draw it out first. Well, I guess that's not true either. It also went up 2 instead of down 2. So, but anyway, I got 0 on my midline. Again, period 2 pi means I stop, or at least one wave ends at 2 pi, right in the middle. That's my midline. Between the first two midline points is my max. Between the second pair is my minimum. Okay, so that's one way from 0 to 2 pi. And then going the other direction, I'm going to go to my minimum first, then my midline, then my maximum, then my midline once again. Oh, yikes. Okay, and again, you can see this B tells me there's one wave from 0 to 2 pi. And in fact, there is only just this one wave from 0 to 2 pi. Okay, I'm going to try to do a couple more of these just so you have a couple more examples to help you out. A is 2, B is 2, C is 0. So amplitude of 2, period, is going to be pi. And I have a midline of 0. I do encourage you to try to calculate the period for yourself. My midline is y equals to 0. And I have my amplitude of 2, so 2 above and 2 below. All right, here we go. And I'm just going to color code here. Okay. And I got my 0, 0, or I should say, in this case, it is 0, 0, but midline for 0. And because my period is pi, I know my ending point is pi. So in the middle, that's also pi. I'm going to go to my max, then my minimum. But I'm going to got to keep going. I go negative 2 pi all the way to 2 pi. So again, maximum, midline, minimum, midline. So my graph looks something like this. Okay, and I gotta do the other side. It's gonna be very, very similar. I gotta go a minimum first, midline maximum, midline minimum, midline maximum, midline. So it looks something like that. So I don't think this is terribly difficult. It's just that maybe it's just starting to pick it up. It might be a little bit challenging. Okay, 2, 1, -1 are my A, B, and C. My amplitude is 2. My period is 2 pi. My midline is y is equal to -1. Again, I'm going to start with my midline at -1. My amplitude is 2, so 2 above and 2 below. All right, and then again, on 0, for 0, I start at my midline. I know my period is 2 pi, so I end at 2 pi. My middle is midline. Between the first two sets is my minimum. I'm sorry, maximum. Between the second two sets is my minimum. And same thing for the negatives. Okay, and so I'm going to connect my points like so. Now, I do encourage you to try to do this for yourself, or at the very least, follow along and draw them out as I draw them out, so you get the practice at least. Okay, and I think we have 2 more. Yeah, 2 more. This one's pretty straightforward. I think that's fine. We'll do it. We'll do it. Okay, this one's pretty straightforward. I got 4, 1, 0 with amplitude of 4, period of 2 pi, midline of y is equal to 0. Okay, and after a while, I think it does become a lot easier to find your values pretty quickly, your amplitude, your period, and your midline. Of course, your period, I would definitely calculate it every time if you need to, right? P is equal to 2 pi over B. In this case, 2 pi is over 1, so 2 pi is my period. Okay, now from here, again, midline is equal to 0. I'm going to draw my midline in, highlight it in this case. I'm going to highlight my guardrails that are at 4 away. So 1, 2, 3, 4. 1, 2, 3, 4. At 0, we are going to be at my midline. My period is 2 pi. That's too far away. In between my 2 points is still the midline. I got my max and minimum like so. And I'm just going to draw all the points here. And plot it out, or I graph it rather. So that's a little sharp. Ugh. All right. It's all right. It's all right. This one's a little. I'm trying to make it straight through, but didn't look quite good. It's okay. 3, 1, -1 is our final example here. My period is 2 pi. My midline is y is equal to -1. Now, if you have any questions about any of these, feel free to ask during support. Oh, sorry, -1. And my amplitude is 1, 2, 3. 1, 2, and 3. Again, I got my 0 is my midline. My period is 2 pi, so I end at 2 pi. In between them, right in the middle, is also my midline. Go between the first two, I have my max. Between the second two, I have my minimum. Same deal for the negatives. And I think something that helps me to kind of graph it out is, especially for the negatives, is again, like, right, your graph should look like this. It should not look like this, right? This is not a sine curve. So make sure your graph looks something like this for your sine. All right, so I think that'll do for this video. I hope that makes sense. If you need help, feel free to come in, Love to help you out.